Alright guys, hey, for 2.5, this is very much a review from Algebra 2. We're going to look at functions and their graphs. So we're going to be looking at transformations of functions today. That's the big idea. So we got three objectives to hit here: graphing functions using vertical and horizontal shifts, graphing functions using compressions, stretches, and then graphing functions using reflections about the x and y axis. So, firstly, to graph a function using vertical and horizontal shifts, you may remember that we use the term inside of a function or outside of the function to determine whether or not something is vertical or horizontal. So we have these parent functions, and I'll start with the easiest one, or the most basic one I should say, and that is the function of a line, y equals x, right? So this is the base function. Now, it's hard to see vertical and horizontal shifts on lines, mainly because well, I'll show you why in a second, but inside the function here means it has to be dealing with this x term. So if I said y equals x plus 3, the 3 is acting outside of the base function. Now, if I put that into parentheses, y equals x plus 3, now we say it's acting inside of the function. Okay, so this, by definition, if you remember from Algebra 2, is a shift of the line, y equals x, to the left 3 spaces. Okay, but with a line, you'll notice that that will graph the exact same thing as this, right? It's also a shift, and if you looked at this graph, on a technical level, this one is moving the graph up by 3. So even though they have the same picture, by definition, one is doing one thing, one is doing the other thing, but that's within lines. So if we go to now something like the y equals x squared function, all right, and we did something similar, what you would see here is very different. Okay, so if I put plus 3 into this, or on the outside of this, it does two different things. For instance, if I said y equals x squared plus 3, if you were to graph that on Desmos right now, or pull out your grapher, you would see that this is the function y equals x squared, which we know is just a parabola that has a vertex at 0, 0, that moves up by 3. You'll see it shift up 3. Okay, if you graphed this one, y equals x plus 3 in parentheses squared, notice that's a much different thing. That's not moving it up 3 anymore. That's moving it to the left 3. So we have this idea of inside the function, inside the parent function, and outside. Okay, this is an example of outside, that's a vertical shift. When it's inside, that's a horizontal shift. Okay, so this is what they're trying to show you here. With a vertical shift up and down, saying you have the function plus something on the outside or minus something on the outside. That's all this is saying. And then they give you a couple of examples. So you have the parent function y equals the square root of x, and then we have a minus 2 that's on the outside of the function. So we kind of know what this looks like. We have a picture of that. And if you forget, it's pretty easy to graph. You could just make an XY table. But then what the minus 2 does to each one of our values is it shifts everything down by 2. Okay, so they show you a picture here. I'm not going to spend a lot of time on it, but here's the original graph, and then here it is shifted down by 2. When you put the minus 2 in, it turns into this red graph here. Okay, so it's just a shift down. So with all of these today, you're just going to be starting with the main parent function and then doing something with it. Now with the horizontal shifts, notice that these happen inside of the function. It's f of x minus h, right, where the minus part comes inside the function. This is what I was talking about, inside the function. So if you want to move something to the right, that's when you'll have an x minus something, okay, because it's whatever makes this go to 0. If you want to move something to the left, it'll be x plus some value, which they call h here. All right, so here on example 2, they're combining vertical and horizontal shifts. So the parent function here, just to be clear, is f of x or y equals the absolute value of x, right? Well, if I want to shift that idea left or right, I have to modify it inside of this function. So what do? They're moving this to the left by 3, okay, by adding 3 to it. And then on the outside, notice they subtract 5. That's going to be a shift down 5. So what you're going to see is you're going to see this line go to the left 3, okay, and it will still have its same shape, right? So it'll do this first, and then it will shift down 5. 1, 2, 3, 4, 5. So we'll end up down here with the same width and depth to the original graph. It's just shifting left and then down. So they show you those steps here. You can also make an XY table to see how this works. You could plug in an XY table and then see what happens with each transformation. But we've done a lot of that before in Algebra 2, so if you feel comfortable just moving it from its base function, that's totally fine. And then objective 2, this is where so that's vertical and horizontals. Now we're gonna compress things and stretch things. So the same exact thing holds up for vertical stretches and horizontal stretches and then compressions. So anything that's happening in the vertical is happening outside of the function. Anything that's happening horizontal is happening inside of the function. Okay, so if we put something out in front of our function, but don't include it inside of our function, that's going to be vertical. So that's what this is describing. This is saying that vertical compressions happen when we multiply our function by something on the outside. Okay, if that thing is between 0 and 1, so if it's like a fraction between 0 and 1, it's going to be a vertical compression. And you can do that. If you want to see that, you can graph something like y equals 1/2 x squared. Okay, and see what happens. And then it's vertically stretched if a is larger than 1. So if you had something like y equals 3x squared. So I challenge you to hop on Desmos or hop on a grapher, graph the two of those and see what they look like, and maybe compare them to y equals x squared and see what that does to them. Okay, so these are examples of vertical compressions and vertical stretches. All right. Horizontally speaking, it's going to be kind of the opposite idea. Okay, so for a horizontal, it has to be a modifier that happens inside the function. So instead of saying like y, like we just had y equals 1/2 x squared, now we have it inside the function. So it would look like this, 1/2 x squared, like the whole thing is squared with the half as well. Okay, so if you do this, notice now that a horizontal compression results if a is greater than 1. So the compression results when a is greater than 1. And a stretch, a horizontal, so this is talking about in the horizontal direction. So a horizontal stretch is actually something getting wider, and a horizontal compression is something getting, squishing inward, so getting skinnier. So it's it kind of works the exact opposite. If something is vertically compressed, it's also horizontally stretched. So vertical compression is a horizontal stretch, but algebraically they look different, right? Algebraically, this one's inside parentheses, so anything horizontal is in the function. And so this is a horizontal stretch. If I did this one, this is a stretch, right, horizontally. And then if you wanted to compress things horizontally, you could put a number bigger than 1 in there, so like 3x squared is a horizontal compression. So again, I challenge you, put those into Desmos, these guys, and see how that changes things. And then they go through some examples here, which I'm not going to roll through all of these with you guys. I think you get the rough idea. And then the last thing is these reflections. So reflections about the x or y axis. These are really simple. So basically, if you want to reflect something across again, I'm going to hit this 3 times now. If you want to move something left or right on a graph, okay, so if you think about a graph, if you move it left or right, that's a reflection over the, here I wrote it wrong. That's a reflection over the y-axis, right? So if you want to move something left or right, it's a reflection over the y. If you want to move something up and down on this graph, it would be a reflection over the x. Okay, so again, if something's moving left or right, it's something that happens inside the function. Okay, so if it's happening left or right, it's going over the y. So notice that the reflection about the y is when you put a negative sign inside the function. All right, if you wanted it to move up and down, then you'd have to have your negative on the outside of the function. That's the reflection about the x. So hopefully that's all review from Algebra 2. Play with this idea in Desmos. So if you don't know how something works, graph a couple of these things, see how it works. Try, for instance, graph negative y equals negative x squared and see how that's different from y equals negative x squared. Okay. See how those two things are different if you're having trouble, wrapping your brain around this. And that's it, you guys. There's a nice summary here that tells you everything about how things move. It looks a little bit more complicated than what I made it out to be, but it's really not. It's just using function notation and showing you. Just notice real quick, like if you take a quick glance here, anything that's vertical, I'm going to go back to my highlighter. Anything that is vertical is happening outside of the function, right? And anything that is horizontal is happening inside of the function. So just kind of keep that in mind. That's true kind of universally. So, all right, that's it for this time, guys. I'll see you next time.